Welcome back to Refactoring Paleo Rows. My name is Tom. We're continuing the process of refactoring our 20-year-old application to something a little bit more modern, a little bit more manageable. As part of this, we're moving our implementation of a SQLite store to somewhere that makes a little bit more sense so we can maintain it more easily and possibly replace it if we decide to in the future. So what is the role of SQLite in Paleo Rows? One application of SQLite in the app is to maintain information about the UI. For example, where the document screen goes. That particular functionality has been used since the beginning of the app and will probably continue for a little while, but we may find a better mechanism for that process. Secondly, we want to manage data tables imported by the user. The user wants to pull in data to be able to plot it in the diagram. We have to maintain those data in memory. Furthermore, it allows users to create subsets of data. The idea is to be able to do a search of your database and be able to pull out smaller data sets to be plotted. So there's quite a bit of information that's being stored by SQLite. And SQLite's a fine technology to use. It's not necessarily something we truly want to get rid of. We may want to get rid of how we're using it, but not necessarily that we're using it. As a brief refresher, here's how we're using it in the document. The document is kind of our focus right now. We want to get the document, which is more or less the core of the application, into a better state. So if we look at the document, again, it's an Objective-C class, and we have a SQLite memory store. And we're storing this in memory, and we're also storing it on disk. The reason why we're doing this is because when it was originally created, performance on disk wasn't particularly great. It was good compared to other things, but it wasn't very good. So the decision was made to store your document data on disk in SQLite, but also to store your data in memory. So this represents the SQLite store. Of course, it's a pointer to the store itself. The store is created in the initializer, and then it is configured in lots of different places. So you can see that we're reading in disk, we are writing to disk, and then further down, we are spending a lot of time configuring the SQLite. We get down there, it's quite a bit down, and here we can start seeing. So this code here creates the in-memory database, and other things are also being done. Now the specifics are a little bit beyond what we want to talk about today, but it is a lot going on. Matter of fact, I think I pointed out, you can see that there are a wide variety of types in here that are touching SQLite. So that's more or less the lay of the land. As I mentioned, SQLite isn't necessarily a bad solution. It's actually a good solution depending on what you're doing with it. But I consider what you just saw to be bad, or at least not particularly great. First of all, the code does work. The application has been working fine for quite some time. And some of you might be thinking, well, the code does work. Isn't that enough? And the answer to that is no, not really. Code could be working just fine, but it isn't necessarily good. It just seems to work. What makes it not good is that it's complicated to maintain, hard to read, that sort of thing. And that's what we really have going on here. It's hard to maintain, hard to read code. Now, I said that the code works, but how do we actually know that it works? Well, to be honest, we only know it works because the app seems to work. There aren't any kind of tests around the functionality. And that's not a good situation because I don't have confidence that the code is really working. It seems to work in the majority of cases, but how do I actually know it's doing what I'm expecting it to do? And the answer is I don't. So the combination of these two things means we should be doing something different than what we have. Now, what I kind of showed you is that we have this in-memory store for SQLite, and we have all these different objects triggering actual SQLite commands directly on that memory store. There's a few problems with that. One is if we start supporting multi-threading, that's going to be a real problem because all these objects may be calling these things on different threads at some point in the future, but also that all these objects know what the in-memory story is. These objects really shouldn't know anything about how I'm storing things in memory or how I'm storing things on disk. They should only know they need to event out certain bits of information in some cases, and they need to take in certain information in some cases. They don't need to know how it's stored at all. So they should not be doing any SQLite whatsoever. What am I proposing to do instead? So what I would like to do is create what I call a document model. The document model is going to store all the information. It sounds a lot like the memory store, right? But what we're doing is we're creating a layer on top of the SQLite store. The idea is none of the objects that are communicating with the document model should know anything about how the memory is stored, just how to pass data to it or get data from it. Essentially, this is like building a facade in between our objects and our memory store. What advantage this gives us is that we can define very specifically the document model's API and tailor to that, to the objects that need to communicate to it. And we can choose to store the data in memory any way we choose. We can swap out the SQLite if we wanted to with something else, or we can just continue to use the SQLite store, and none of the objects would be the wiser because they don't care. And if they don't care, that means we've pulled apart these objects in terms of how strongly connected they are. Now, this diagram isn't exact. I don't know what the ultimate structure will be, but the idea behind this is very simple, straightforward. But going from this to this isn't exactly a one-step process, because if all these objects over here on the right know about the in-memory store, we have to start breaking that up piece by piece. And that means the document model will have to take up all that information and be able to handle all that storing that all these other objects were doing. So that's going to take a bit of time. So today we're just doing first steps. We're going to create a document data model. Its job will be that facade between all the memory that the data require, or the document requires, and all the data that the objects require. Within that data model, we're going to create a new home for the SQLite in-memory store. No longer will it be stored in the document like I showed you earlier, but now it's going to be stored within the data model. So the SQLite in-memory store should be created within the new model. The memory store should also be available to the document and function as before. And this criteria here is a bit weird because I can't fully remove SQLite from all those other types in one step. And the document is controlling all the access to all those other types to that memory store. So the first step is get this stuff isolated, but we're going to temporarily expose it to the document so the document can still behave as before. And so when we commit the project, it will still be functioning, but now it'll be a slightly different arrangement. And the SQLite memory will have to be closed. Well, where that closure is going to be, it's probably going to be associated with closing of the document data model, but it's going to have to be closed at some point. So this is not a very ambitious set of things, but it is a necessary step to start before we can start moving all these SQLite calls into the document model. Okay, here we are in Xcode. So what we need to do is go into our Xrows document and take a look. So if you remember, we are using an in-memory store with SQLite, and that's located here in our document. We create the SQLite store in the documents init method, and we destroy it in the dialog. Again, the problem is that this memory store is being used all over the place. You can see being used here. Much further down, you can see there's all sorts of SQLite calls in the document. So eventually what we're trying to do is move all of this out of here and put it somewhere that makes a little bit more sense. There's just too much going on in a document anyway. So what can we do? So I'm going to create a new directory in here. I'm going to call that document model. And what this document model will be is actually several different things in the end. First, we're going to provide an interface for anywhere to talk to the document model and get the data they need, or insert the data into the model that's been updated. But none of the other types need to know any of the details of what's going on there. We want another layer that's actually our SQLite store. And then realistically, we'll want another layer that is actually handled by either off-the-shelf SQLite library or a custom one. Now, I'm probably going to use a custom one because I'm interested in experimenting with different techniques to use SQLite and Swift. But usually I would recommend just pulling something off the shelf. So in a way, we have about 3 layers down. One to handle the interface, one to talk to the SQLite store, and one that's actually doing the SQLite stuff. So let's start by creating a type. We'll make it our document model. Normally what I would do is I'd start with a struct. Structs are the direction Apple is going. So if we're looking at Swift UI, that sort of thing, and newer technologies, it's all around the struct. It's around the idea of immutability. But in this case, we have a couple of problems. One is that we're managing state for a lot of things, so we probably want a class. But we have one more issue on top of that. And that issue is this guy is going to be talking to Objective-C code. So we're probably going to have to make it an subject subclass. Eventually down the road, once this Objective-C code starts going away, we should be able to get rid of that out of this document model. And maybe okay, so what do we need this to do? We don't need much right now. So remember, all we're doing is essentially moving this and moving this and this to somewhere that makes a little bit more sense. We could create another object that manages our in-memory store and just start with that. So let's go ahead and create that. So again, there's a possibility that we may have to invoke this from Objective-C. So temporarily, at least, let's go ahead and call this an NS object. So this is where we want to do the stuff the document was doing before. If we're going to be managing this in-memory store, we're probably going to have our own pointer. not the best names, but we're going to make it an optional because it could fail when we create it. But now we need an initializer. So we can do one of two things. We can go this route and initialize it with a pointer, which is dependency injection. Or we can create the pointer here. If we do it here, this is where the pointer will be created. We don't necessarily want to actually create the SQLite pointer in the initer, but we can if we choose. Now, ultimately, whatever library we choose to use, or our own custom code, should be responsible for creating that pointer. But for right now, we need something that will create the pointer for us. So we'll need to import SQLite here. Okay, I came up with a better name, SQLite store, than pointer. There's two different versions of open that we can use. I'm going to use the more complex one, not for any particularly good reason, but I'm just going to use it. And so we can use this particular command to create a unique identifier for our SQLite store using the UUID, set the store, and make sure it is an in-memory mutable SQLite store. Now, what happens if this fails? Which it can do. One, the pointer will be null, and the result will not be exactly what we want. Sorry, this is Objective-C underneath the hood, so I have to write overwrite. What this is telling us that we need to make SQLite store a var. So usually my rule is if we can get away with making a let, in other words, immutable constant, and just initialize it in the initer, go with let. But sometimes you have no choice, you got to go with var. Result can be a success or a failure. What do we do about it? We should handle that error. So the only thing we're looking for right now is that the result is an OK. So if that is not OK, then we have a failure. Now, if this was pure Swift, I would probably have it throw. But since it isn't, since it's actually got an Objective-C at some point, we need to make this, for right now, I'm just going to log it. That should be a print anyway. This should be able to create an in-memory store. But we also want to deallocate. So with DNets, we want to make sure close is called. So right now, this is all our in-memory store is going to do. Now I could unit test this, and I probably should have tested it in, but a lot of this SQLite stuff is going to move somewhere else even further. I'm going to leave it there for now. I just want it to work. Now, if you remember, going back to our document, we need the pointer up here to be able to do all this other stuff. How am I going to do that? Well, that's pretty simple. We're going to make an accessor for that. Now, if we did make this private, it's just be there and we can access it. But sometimes I think writing a function is better than just letting you access the variable, especially when it's mutable. Just call it the store, and it returns an opaque pointer. Because that's optional up there, we want to make it optional. Now, to be honest, looking at this as we're doing it, I would actually rather move this initialization function into its own thing, because we don't have to do it in init anymore. So let's do private function. Let's just move all of this into our create store function and just get rid of the initter. Why did I do that? Well, so this isn't the prettiest of things, but if this turns out to be nil, let's create a store and return it. So now we don't have to create the store in the initter. We can now just, whenever we ask for the store, it'll create one and put it in here. We're only making this store available because the document needs it for now. And all the other classes that need to update the SQLite store need it for now. So what we need to do is go ahead and deprecate this method. To deprecate it, we just put in a requirement here that it is deprecated. Why am I doing that? Well, this will generate a warning saying that this code is going to go away. And that's what we want it to do. We wanted this code to go away. If for some reason we change our mind, we can just get rid of that line. Now remember, the in-memory store is going to sit underneath the document model. The documents model is going to be what doles out the values and takes in the changes. Update the document data elsewhere. So what do we need? Well, we're going to need the in-memory store, of course. So we need to initialize. Now, at first glance, this seems pretty reasonable to do it this way. And of course, Objective-C under the hood, so we have to override. The problem with doing it this way, creating the memory store in the initter, is that if we want to test it, it makes it a little bit difficult. So we could do a bunch of different things. What I would normally do is something like this. So this is dependency injection. I can inject this in-memory store into the document model. Just create it, inject it, there it is. But it doesn't work here because of the way Objective-C works. Now you can set this sort of thing up like this for Objective-C. And we'll probably have to make it a var. But you can't have the default value. And because we can't have the default value, we need to inject the in-memory store in a slightly different way. Oops, gotta make a self there. So that means when we create the document model, for now, we're going to have to inject the memory store all the way up the document level. Add the document model into the document. Now for this to work, we need to bring in import. Just make sure we can build. So where we're going to create the document model? Well, we're basically going to do it right here. Helps to remember what language I'm in. Now, I forgot something that we need to go back. We have to make sure the function is Objective-C. I probably need to do that elsewhere as well. Just for safety's sake. There we go. Okay. So now we have our document model created and stored here. Let's see if we can build and run. Great. It appears to be working. Now, we still need to get access to the memory store, which is a couple layers down now. So I'm just going to move some of this up. And we're just going to talk to in memory store. Hopefully that will build. We'll see. SQLite jumping in. And let's see if it still works. Okay, fully built. So we now have access to the pointer. So in theory, we don't need this anymore, or this. Let's get rid of that. Get rid of that. Now the problem is we can either hold on to this, it might be slightly faster, or we can actually access the value from the document model. So let's see what happens if I comment this out and build. We have a lot of places that aren't happy. We could either say so now we want to try to go to the document model and ask for the store. So it's saying it's deprecated, but it should work. So I'm selecting all of them that I can. And there is a lot. I think that's the last one. Okay, it's successfully built. So we got rid of our dealloc, and we got rid of the creation of the store. And now we're just using when we move down. There's a layer, there's data. Seems to be working just fine. Okay, we're getting a lot more warnings, but we expect to get those warnings. In the future, we can probably spend some time making this simpler. Eventually, these warnings will go away as we move all this somewhere. Next time, what I want to start doing is fixing this. This function or method creates the database. We can't structurally change this database at all at this point. We just need to make a much cleaner way to create it. There's a lot of repeated code in here, and it's just not pleasant to deal with. So we made a critical first step. So just to review, we changed how we're using the SQLite store. We originally was building it within the document, but it doesn't make sense to do it there. Instead, we're creating a document model that the rest of the app will eventually interact with. And we're saying set values, give me values through the document model. The in-memory store's job is just to manage the in-memory store that we're using for SQLite, as long as we have it. We may just be able to get rid of it altogether and just talk to the disk directly, because computers are getting much, much faster than they were when I first wrote this. But even so, we'll need to have one thing we didn't do, again, was write unit tests. In an original draft of this, I did do unit tests. I did TDD of it. I decided to show you that would take a lot more time. I will occasionally, from now on, write tests, but I may not necessarily show myself writing these tests. I will probably spend a few episodes here and there going through the tests and how I write them. But in this particular case, all this code is just throwaway code, temporary code, until I get something better in place. The main thing was start pulling this stuff out of the document. It's not quite to its final home yet, but we're getting there. Well, thank you very much. Next time, again, I'll pull more SQLite calls out of the document file, and then the document file is going to start looking better and better. Thanks. Leave a like and subscribe, and leave a comment if you have any questions or thoughts about this particular episode. My name is Tom. I'll talk to you again next time.